Hello, this is Richard White with an Introduction to Spreadsheets, Part 5. In Part 4, we looked at using a spreadsheet to set up a data table and then create graphs or charts of that data using Microsoft's Excel. Now in Part 5, we're going to see how to use Excel to do some simple analysis of our data. There are lots of different ways to analyze data. In this example, I've graphed position data as a function of time for a ball rolling down a ramp. It appears to me visually that the ball's position keeps changing by a greater and greater amount for each time interval that passes, and that's certainly what I observed during the experiment. You can also see that although there's a general trend upwards in my graph, the data points that I've plotted don't appear to follow a smooth curve. This one's a little low, and this one might be a little bit high. That might mean that I've made a mistake in my measurements. If any of these data points were too far off, I might consider remeasuring that data. But it could also simply be a result of experimental uncertainty. That is, I'm limited in how well I can collect my data. My stopwatch only measures to the nearest hundredth of a second, although that's pretty good. My biggest source of experimental uncertainty is simply that it's hard for me to measure the position of the ball as it's rolling down the ramp. I've indicated the position of the ball in meters here to the nearest hundredth of a meter, a centimeter, but my measurements are probably only within 2 or 3 centimeters of the real value, especially when the ball is moving more quickly. What I'd like to do here is to be able to use my data, even with its uncertainty, and a model of the ball's motion to see if I can better understand that motion. In statistics, if you want to find the relationship between two variables, you can do a regression on your data, and that's just what we're going to do here. We're going to have Excel look at the values I've collected and see if it can figure out some pattern in that data. Excel, perhaps because of its use as business software, calls this analysis by the name trends, but it's really a regression that we're doing. Let's see how to go about doing that. Begin by clicking one of the data points to select the data that we're going to be analyzing. You can see our data set that we used to create this graph highlighted. Now go to the Chart menu and choose Add Trendline, and immediately you'll see Excel's analysis of our data. It has added a linear analysis of our data points and displayed that line on the graph. I don't like this line very much, though. It doesn't really appear to fit my data very well, does it? The data points at the beginning and the end are above the line, and all the ones in the middle are below the line. Excel has just assumed that I'm looking for some sort of linear relationship with my data. But it turns out that position versus time for objects accelerating down a ramp is not a linear relationship. Excel doesn't have any way of knowing that, of course. It's up to me to try to choose the correct model to analyze my data. In the course of your data collection, you may have the occasion to work with linear data sets, exponential data sets, power data sets, and possibly others. For me, to help Excel analyze my data, I need to think about what pattern in my data I might be expecting to see. In the course of my study of kinematics, I've learned that the position of an accelerating object can be described by this equation. D, displacement, is equal to VI, initial velocity, times the time of travel, plus 1/2 a, the acceleration of the object, times t squared. What kind of equation is this? If I rearrange the equation to look like something that I might do in math class, it looks like this. And I can see that if I simplify this a little, it starts to look like something t squared plus something t plus something equals 0. That's the form of a quadratic equation. Because I'm graphing objects that are accelerating, it makes sense then that my graph would have the shape of a quadratic curve. And if I want Excel to analyze my graph correctly, I need to tell it to not look for a linear relationship, but a quadratic relationship. In math terms, this quadratic relationship is called a second-order polynomial. I'm going to delete my old trend analysis here by clicking on the trend curve and pressing delete on the keyboard. Now I'll do a new analysis. Click on the data set, choose Chart, Add Trendline, and select Polynomial for the new analysis. And look at the curve now. Notice how much better it fits the data for this experiment. My data points don't fall exactly on the curve, again, due to that experimental uncertainty that's a normal part of any measurement. But they're pretty close. This looks good to me. The last thing I think I want to do here is actually see the quantitative analysis that Excel has done here. The trend line that Excel placed on the graph looks good to me visually, but I want to see the actual equation for that line. I might even use the equation for that line to analyze my results. Let's have Excel display that information for us. I'm going to double-click on the trend line to bring up the Format Trend Line dialog box, and I'm going to click on the Options menu item. I'm going to click both on the Display Equation on Chart and Display R-Squared Value on Chart checkboxes, and then click OK. Let's see what that does for our graph. The first thing we see is that we now have a function of our graph. This equation here is the equation for the line that offers some sort of best fit for our data. I can even take that equation and use it to find out that the average acceleration of my rolling object appears to be about 2.6 meters per second squared. I'll leave that as an exercise for you to determine how I figured that out. The R-squared value here in statistics is called the coefficient of determination, and it's simply a rough measure of how well the data and the regression model match each other. The closer this value is to 1, the better the data fits the model being used to analyze it. You can see here that our data matches the quadratic relationship very, very well. At this point, you'd probably like to be able to make a copy of your graph to be displayed on a web page or in a report. If you'd like to copy it to another Microsoft application like Word or PowerPoint, you can simply click on the area of the graph and select Copy from the Edit menu. Then move to the other application and paste it there. You can also create a graphic image of the graph by right-clicking or control-clicking on it and choosing Save as Picture, as you can see here. Here in Part 5 of our Introduction to Spreadsheets series, we've seen how to use Excel's trend lines to do a regression analysis of our data and how to export our graph for other uses.